I had two actually.
Okay.
The first one, can you just clarify what you said yesterday about the parietal duct? The
With
talks about the
parotid duct.
yeah.
Okay. Well, that's me. That's okay. That's the duct that goes from your parotid salivary glands and releases saliva into or carries the saliva to the buccal cavity. That was all about it.
Okay. And then the other one was, um, did you say the mucus that's for protection in your stomach? Did you say that had a name?
That had what?
A name? Was there
No,
a name for it?
no,
Okay.
it
Okay.
doesn't have a name. It's just like you can say it's okay, a slimy film of something that looks like phlegm or mucus. But me, that's okay, just a protective lining that protects the stomach from being acted upon uh, by the strong acids or the hydrochloric acid. Okay, so
Okay.
in some instances, okay, either somebody produce too much acid that will lead to, yes, okay, what we call heartburn. In some instances, okay, it can be because that protective mucus layer actually is okay get defective. So that means okay are going to be areas in the stomach wall where there's not going to be any mucus protection, which mainly causes that area will be exposed to the acidic contents of the stomach, which actually is okay starts to erode the stomach wall and produces what we call a stomach ulcer.
Okay. Makes sense. Thank you.
But the mucus as such, no, it doesn't have a name. Okay,
Okay. Thank you.
no problem there.
I have one question.
Go ahead, yeah.
So in the respiratory system, I know you said in the alveolus the blood gets filled with fresh oxygen as exchange.
Yeah.
But specifically, is it the hemoglobin in the blood that gets the
It's
oxygen?
yeah, because that's going to be what mainly is okay. Picks up the oxygen in the red blood cell and carries it onto to your body cells. But it's not going to be a crime to say that okay, it's picked up by the red blood cells. Okay. Okay. It's even okay to say that it's picked up by the blood. Okay.
Okay.
Anything else? Okay, so just a few pictures that I didn't get the chance to show you guys yesterday. Pictures are pictures. So. Okay, so yes, okay, again, as we said, this is pretty much okay, yes, what your stomach will look like. Okay, so this was the fundus, the main body of the stomach, and this would be the pylorus. Okay, if you look on the, sorry. So what remains as okay between the liver and yes, okay, this lesser curvature of the stomach, that's where we had the lesser omentum. Okay, running off from the greater curvature of the stomach, we had what we call the greater omentum or the fatty apron. Okay. And this is going to be as okay, what we'll call the pyloric sphincter. Up here is okay, we have what we call lower esophageal sphincter, or they may even call it as okay the cardiac sphincter, mainly because it's pretty much okay as this area between the stomach and this area of the stomach where the esophagus meets. That's going to be called the cardia. Okay, and the bulge of the stomach above the cardia, that's going to be referred to as the fundus. Now, please remember this name fundus because it's going to just repeat it again for another organ in another system, which is made as going to be the name of that area of that organ or structure, whereas something meets it. Okay. Yesterday I said that as once you eat and drink, your stomach mainly is going to start churn on the food, pretty much not only just chemically digested, but you can see it's actually it's also mechanically digested. So both as chemicals, different enzymes, for instance, gastric juices. But I mean yes, due to this movement that you may see is in this one here over here is mainly as what we can call as the movement. It's not going to be only seen in the stomach, but pretty much throughout your entire alimentary canal. That's pretty much as how this kind of movement here that occurs, which mainly as processes the food. And that movement is going to be as what we will call peristalsis. If you look down here, well, yes, pretty much as two pictures of one mainly as would be yes, stomach ulcers. As I say, yes, if the acid, for instance, yes, acts upon the stomach wall, you actually yes, may develop wounds like these. And in some instances, these wounds here or ulcers actually can get malignant, which as will not lead to something good. Okay. Good. Okay, guys. Hold on.
Sorry, what did you say was called the movement where the stomach processes the food?
Well, not just the movement of the stomach. It's pretty much going to be the movement of all of your alimentary canal. And that's going to be called peristalsis. Let me just write that down for you guys. And we can even see what that would be. Okay. So what that means is that's going to be the movement of your alimentary canal. And now have any of you ever seen an earthworm moving? Yeah, that's pretty much it's what it looks like. So actually it pretty much looks like those kind of movements that an earthworm is producing in his body as with help of which actually move from this point to, let's say, this point. So that's pretty much as what peristalsis is going to look like. And with help of that, yes, what does it do? Mainly as because it's pushes the contents of the gut or of the alimentary canal from one point to another, from one point to another, from one. And pretty much yes, you can say churn it around so that yes, as much food as ingested. Possibly, as okay, will get exposed to the digested juices, etc., which is going to, as okay, make it become digested. But also, as okay, mechanically, as okay, further digested by the motions of the gut. Okay, guys. Now, if we said, okay, yes, we had the esophagus. Let's just move into focus. This was the esophagus. We said that we have the stomach. And what we mean, you can say is, okay, that the end part of the stomach is going to be called the pylorus. At the pylorus, do we have, yes, okay, a sphincter called the pyloric sphincter. Okay. And what I said about the sphincters was that, okay, as these are mainly, yes, okay, going to be reinforcement of, okay, the circular muscles in your alimentary canal that mainly, yes, okay, will form this valve-like structure. Now, after, yes, okay, the stomach, we mainly, yes, okay, going to have, yes, okay, what we call the small intestine. Okay. Now, what we said was that, okay, the small intestine mainly, yes, okay, was made up of three parts. The first one, which is going to be, yes, okay, the most well-defined, is going to be, yes, okay, what we call the duodenum. Which means, yes, okay, is going to be followed by, yes, okay, what we can call the jejunum. And finally, yes, okay, is going to end up in what we call the ileum. Now, on the surface, yes, okay, if you look at the jejunum and the ileum, structurally, arrangement-wise, yes, okay, they're going to look pretty much the same. Okay, the part of the small intestine which actually is okay has a very specific form or shape is going to be the duodenum. And due to that, that's why it's okay. We're going to mean is okay. Focus mostly on the duodenum in the small intestine. So the duodenum, that's okay. That's going to be yes, okay. How long? 12 inches. So it actually is okay. It's only yes, okay going to be 1 foot long. Okay. Now that 1 foot or 12 inches long, that's provided that okay, yes, we straighten it out. Because okay, the way that it is mainly is okay is arranged inside the abdomen of a person is that it's going to be C-shaped. So the duodenum actually that's okay is going to be C-shaped. Like this. Did you guys get that? Okay. Now, another thing that we said about the duodenum yesterday was that the first 2/3 of it was part of what we call the foregut. So we can mainly say, okay, that if we divided the duodenum into 3 equal halves, the first 2 halves was going to be, okay, part of the foregut. Where we also said that, okay, yes, the one last third was going to be part of the midgut. Now, what we made, yes, okay, just will have after this is going to generate, yes, okay, first will be, yes, okay, the jejunum. Okay. Followed by the ileum. Okay. But your ileum is okay in normal people, yes, okay, that's going to, yes, okay, end in the right iliac region. Okay. Mainly, yes, okay, because this is where, I mean, yes, okay, is going to join with the cecum. Okay. So that junction between the ileum as the last part of your small intestine and that of the cecum, after which is okay, your colon begins. That is going to happen at the, or happen in the right iliac region. Did you guys get that? After which is okay, we will have the large intestine. Now, guys, let's just look at the duodenum. As we said, we can just, okay, let's see, it's okay. We can still make it, okay, the stomach, so we know that, okay, yes, what we are talking about. So this is the stomach. This is the duodenum. And what we mainly is, okay, are going to have is, okay, in the proximity of the stomach and the duodenum is going to be, as okay, as a matter of fact, is okay, the largest gland of your body. That's okay, gland of your body, which is going to be the liver. Okay, we will talk a bit about, yes, okay, the liver in a little bit. Okay, now with the liver, yes, okay, we have, that's okay, the gallbladder. Okay. Now, in this region here, pretty much, okay, as in that curve of the C of the duodenum, that's made as, okay, going to be as, okay, where other gland fits. A part of that gland is going to be fitting, and this gland here main is going to be the pancreas. Okay. As a matter of fact, that's okay. If you look at the pancreas as such, okay, it may look like, okay, as a tadpole or a leech or something like that. So this part here, that's going to be as, okay, the head of the pancreas, which means, okay, fits into this curve of your C-shaped duodenum. After which we mainly as okay, the main part of it is going to be as okay, the body. And the end of it is going to be as okay, the tail. Okay, so we can mainly say okay, the part of the body that just okay, let's make it a little bit distinct. So we say okay, this is the body. Part of the body is going to be here. Part of the body is going to be of the pancreas is going to be behind the stomach. As a matter of fact, not only behind the stomach, but even as okay, also behind your peritoneum. So that means okay, makes all of your pancreas being what we call retroperitoneum. Okay, and last but not the least, yes, okay, is going to be okay, the tail of the pancreas. Okay. So most of the body of the pancreas and the tail of the pancreas mainly as okay is going to be located behind the stomach. Okay, whereas okay, yes, the head of the pancreas pretty much okay fits into this C-shaped curve formed by the C-shaped duodenum. Did you guys get that?
Yes.
Now, as our pancreas is concerned, or like it's a unique organ, it's a unique gland in the sense that this is going to be both considered to be an endocrine gland. Okay. Now, what makes it an endocrine gland? Mainly because okay, the secretions that it produces are going to be released into the blood. Okay. And those secretions are mainly going to be as okay, some sort of hormones. Okay. So the major hormone that's going to be produced by your what the hell do you call it? Pancreas is mainly going to be insulin. Okay. There's going to be another hormone produced by your pancreas, which is going to be as okay, what we will call glucagon. Okay. And okay, as we may talk about this later on, as okay, both of these as okay are going to be as okay, playing a role in okay, as regulating your blood sugar. Okay. Did that make sense? So mainly because okay, your pancreas produces these hormones here that makes it an endocrine gland. Okay, but your pancreas is also going to be as okay and exocrine gland. Okay. Now, why exocrine? Mainly because okay, it produces some secretions which are not going to be released into the blood. So those secretions will not be hormones. Okay. Now, not to go into yes, okay, the details of the names and so on. So right now, but our question mainly going to be as okay, if the secretions produced by the exocrine component of your pancreas doesn't end up in the bloodstream, then okay, where do they go? And they are mainly as okay going to be as okay released into the duodenum. Now we can say okay, now it's exocrine. That's mainly going to mean that okay, there will be a duct. So the pancreas actually is okay, are going to is okay have a duct. Okay, through which is okay substances or secretions are going to be released into this duct from the exocrine component of your from the pancreas, and that duct is going to just okay open up into the duodenum. Okay, and literally just okay where? Well, okay, if this is the duodenum, if this is your pancreas, we can say it's okay, the pancreas is okay, have a bigger or thinner, bigger or smaller duct. That duct is mean it's okay going to open up somewhere here. And that actually that's okay is going to be as okay a little opening. Or actually that's okay a sphincter. And we call that one the sphincter of Oddi. Okay, so this is mean it's okay going to be the sphincter through which primarily we can say it's okay that your pancreatic duct is going to is okay open up or is okay enter into the duodenum. And pretty much okay as whatever secretion is okay was produced by the duodenum, that's sorry. Okay, which is going to be as okay exocrine. Okay. Because okay, the secretion does not end up in the bloodstream, are going to just okay be released into the duodenum through the pancreatic duct that opens up at the duodenum through what we call the sphincter of Oddi. Did you guys get that?
Yeah.
Yes, thank you.
Any questions so far?
No.
Everybody is clear?
Yes.
Okay, good. Hey guys. Not to go into this, okay, a lot of detail, we probably is okay talk about that in a little bit. But pretty much okay, yes, since we are at the sphincter of Oddi and the pancreatic duct, there's going to be as okay another kind of duct that pretty much okay as comes from your gallbladder. So we can make it okay, let's do it this way. We say it's okay. We have the liver. So this will be the liver. We can say it's okay, we have the gallbladder. We talk more about it's okay what the functions of the gallbladder and so on so is once we talk about the liver. Okay, now from the gallbladder is mean it's okay going to be it's okay a duct. That means it's okay it's going to be a duct that comes from the gallbladder. Okay, now since it is a duct, it's going to be called duct. Since it comes from the gallbladder and the word bladder, that's why we'll call it the cystic duct. So there's mainly going to be a duct through which the secretions from the gallbladder is going to be carried. Okay. We mainly we also have another duct coming from the liver. And if you just say the duct from the gallbladder was called cystic duct, the duct from the liver is just going to be called the hepatic duct. Okay. And at some point, these two ducts here, will meet. No, they will meet. And actually, form what we call the common bile duct. Okay. Now on your systems, ultrasound systems, you may see something being abbreviated as CBD. No, that is not a cannabinoid. Okay, guys, don't say as if I push this button, I'm going to be getting some cannabinoid or cannabis or weed. That's not what it means. It means just an abbreviation for the common bile duct, CBD. Okay, and this common bile duct, which mainly gets or carries secretions both from the liver and from the gallbladder. Now, this is going to run posterior to the duodenum. Okay, this common bile duct is going to run posterior to the duodenum and pretty much, come here. Okay, now in some instances, guys, well, this is an area, where there is going to be, you can say, some anatomical variations from person to person to person to person. You how and where the cystic duct and the hepatic duct meets, and the kind of networking that they form is may vary from person to person. Okay, so but commonly, this common hepatic duct here will also open into the duodenum via the sphincter of Oddi together with the pancreatic duct. Did that make sense? Okay. In some instances, may not open, into the duodenum together with the pancreatic duct by through an opening of its own. Okay. Did you guys get that? So it is an area of some anatomical variations. But commonly, we see that in most instances, that the common pancreatic duct opens into the duodenum together with the, through the same opening through which the pancreatic duct comes in. Okay. What makes up the common bile duct? This is a must to know, guys. The common bile duct actually is going to be made up of the union of what we call the cystic duct and hepatic duct. Okay. So these two ducts here coming together mainly is going to be what forms what we call the common bile duct. And this common bile duct here is opens into the duodenum. Mostly as together with the pancreatic duct through as the sphincter of Oddi. Did you guys get that?
Yeah, you said the cystic duct and the hepatic duct equals the common bile duct, and then opposite to the duodenum.
No, it opens up into the duodenum.
Thank you.
Okay. Let's take it at two roads or streets that merge together to form a highway. One came from the cystic city, one came from the hepatic city. And that common highway is going to be called the common hepatic, not common bile duct. Yeah. Did that make sense?
Yes, thank you.
No problem. Okay, guys. Yeah, I know this system is a little bit all over the place because, well, a lot of things are interlinked. Okay. Okay, but okay, guys. So we can make it these will be as main two or the main two ducts that as will open into the duodenum, respectively as from as two major organs, or sorry, glands. The pancreatic gland or the pancreas and the liver. Okay. And we're going to talk a little bit separately about the pancreas and the liver later on today. So let's just get back to to our favorite fellow, duodenum. And we can say it's we had the stomach. In the stomach we had the pyloric sphincter. After which we have the duodenum. Okay. Which mainly was going to be followed by the jejunum, which eventually was going to be followed by the ileum, after which we'll get the cecum. Now, guys, one thing that we said about the stomach was that the stomach had a very low pH. was anything between 1 to 2, which made the stomach extremely acidic. Okay. The way or the reason that, okay, yes, the stomach was not being normally affected by this acidic environment of the stomach itself was because it had, okay, as a protection in form of a mucus film. Now, what's going to happen once whatever you ate, whatever you called it, enters into the duodenum. Okay. Now, the constant of yes, okay, the stomach that enters into the duodenum, yes, okay, as I said yesterday, that was going to be called chyme. Okay. Now, what your duodenum is going to be having now is, yes, okay, the duodenum that's going to have more of an alkaline pH. Okay, something about, yes, okay, something between, yes, okay, a pH of 8. Okay, so one thing that your stomach is okay, that your duodenum actually is going to do is, it's going to, yes, okay, release a substance called sodium bicarbonate. Okay, which pretty much, okay, is going to, you can say, okay, actually going to buffer the acidic contents released by the stomach. Okay, now what we mean is, okay, by buffering is mainly going to mean that, okay, as if it's an acid, it's going to become alkaline. If it was an alkaline or a basic, it's going to become acidic. Okay, so sodium bicarbonate, that is actually, that's okay, going to be a substance that is going to be, okay, released by the duodenum. And what it means it's going to do is, it's going to, okay, somehow reduce the acidity, or actually, it's okay, make the contents of the duodenum become more alkaline with a pH of approximately 8-ish. Did that make sense? Okay. Now, primarily as okay, due to as okay, the substances coming as okay via as okay CBD from the liver and gallbladder. Okay. Okay. And we can say as okay, different digestive juices and enzymes coming from the pancreas released into the duodenum. Mainly, yes, okay, is going to lead to, yes, okay, that this area here is going to be, yes, okay, a major area for your chemical digestion. Okay, now what did we say digestion was? Breakdown of food into nutrients. Okay, and when that digestion was due to chemicals, which in this case, yes, okay, will come from the pancreas and from, yes, okay, your gallbladder and liver. That will be, yes, okay, an example of chemical digestion. Did you guys get that? Yes, guys.
Yes.
So we can say it's okay. Generally, it's okay. What's going to happen here is, well, okay, there's going to be, it's okay, a lot of enzymes I'm released. We can say it's okay. One would be, it's okay, what we'll call maltase. Okay. And maltase, as you can see, is okay, acts on maltose. Now, if you look at the word maltose, it's a sugar. Okay. And this maltose here is okay, mainly is okay, is going to break up into glucose molecules. We can say it's okay, that's going to be it's okay, another enzyme called sucrase. And that's mainly going to act on sucrose, which again is going to be a sugar. And that's going to mean it's okay, break this sucrose into what we'll call glucose and fructose. Now, mainly that's okay, we'll just write this in yellow because this mainly that's okay comes from your pancreas. And that is going to be as okay, amylase. And amylase, as okay, is going to act on starch. And mainly as okay, as we know, that starch was mainly as okay, just a long chain made up of a lot of glucose molecules. That's going to just okay, release a lot of glucose. Okay. And this amylase here, that's going to just okay, enter into the duodenum. Primarily, not primarily, is okay, well mainly is okay, comes from the pancreas. So that's why we can call this okay, pancreatic amylase. But even if you just say amylase, that's okay, that would be good enough. Now my question will be, which other secretion produced by your body had amylase?
Your salivary glands?
Saliva, right? Okay, saliva was having amylase. Did that make sense? So that's okay. Here you can mainly say, okay, that starch maybe is okay, a stubborn molecule because okay, it may not be fully broken down by saliva. So later on, yes, okay, there's going to be, yes, okay, another gland that mainly, yes, okay, still will produce saliva. Oh, sorry, amylase that's going to, yes, okay, act on the starch and break up this starch molecule and release a lot of glucose. Okay. Besides that, we can say, yes, okay, there's going to be, yes, okay, something that we call peptidase. Now, since it ends with A, just okay, just makes it an enzyme, which is going to, yes, okay, act upon the peptide bonds. And where did we have peptide bonds? Between the amino acids that made a protein. So peptidase, yes, okay, that would pretty much act on these peptide bonds here. And we can say, okay, mainly as okay, break up some of those bonds. Mainly says, okay, we have the nutrients that was going to be released by the digestion of this protein here, which was going to be the amino acids. Okay. There may yes, okay, be a substance called nuclease. Now, if you look at it, it's probably obvious as okay, what this is going to be acting upon. Your nucleic acids. And again, yes, okay, just release those proteins, sorry, amino acids that made up, yes, okay, your nucleic acids. Well, that's okay, the nucleic acids, prime, yes, okay, from, yes, okay, the living organisms like you're having a steak, you're having chicken, you have fish, etc. That flesh or meat, whatever you want to call it, it's okay, has nucleic acids. But they are going to be acted upon what we call nuclease. Okay. We can say, okay, there's going to be another hormone, not hormone, sorry, enzyme or lipidase. Now that's me as okay, that's going to act upon as okay, lipids or fats, and mainly as okay. For me, it's okay, said that fats was going to become is going to be as okay, what we call fatty acids. Did you guys get that? Right.
I have a question.
So, yes, my dear.
What is the difference between pepsin and peptidase? Pepsidase, sorry, I don't know. how to say it.
Peptidase,
Yeah,
but we can maybe say pepsin is primarily as okay released and produced in the stomach.
okay, but they both break the peptic bonds, like both of them do?
Exactly, yeah.
Okay, and then just one other question. So you said the amylase, I don't know how to say it, I'm sorry.
Amylase.
Amylase, also, okay, so the amylase is from the pancreas. All these other enzymes you're talking about, are these from the duodenum?
But
like the
some of
top?
them could be from the pancreas, some of them will be from the liver.
Okay, that's all. Thanks.
Now, guys, there's going to be one thing that you may eat, which is not going to be a nutrient. Well, let's put it this way. It's not going to be a nutrient for us mainly because we as humans don't have the enzyme to break it down. Okay? We as humans don't have the enzyme to break it down. So that's why it's okay. It will be, it's okay. Because it's okay, pass undigested through your alimentary canal. And it's okay, exit out at the other end. Okay? Now that substance. Okay? Okay, guys, let's put it this way. And please mind, guys, okay, as when I say not digested, yeah, I'm talking of chemically digested. And if you look at the word, you say, okay, but why in the... Let me just... Why don't we? Cellulose. Now, if you look at it, you will say, okay, isn't this okay as a form of carbohydrate or sugar? Yes. Now, please keep in mind, guys, when I say sugar, sugars don't necessarily have to be sweet. Okay, okay. So there is a sugar called cellulose that we as humans can't chemically digest. And the thing here is chemically. Because, okay, you can digest it. But we can't chemically digest. Whereas, okay, we can digest it. Mechanically. Okay. Primarily, yes, okay, how is that mechanical digestion going to happen? Pretty much okay as by chewing. Okay. Now, where do you find cellulose? Because it's okay, it is found in things that we as okay may eat. But the reason that we can't chemically digest it is because it's okay, we as humans don't produce the enzyme that will act upon this molecule here, just okay, break it down into to the nutrients. So guys, where do you find cellulose? In the skin of beans. Even as okay, that skin or a covering of a corn seed. Clear? Okay. Now you may say, okay, well, how do we actually okay digest? Are able to okay digest the pulp inside the corn? Or it's okay, actually it's okay being within the skin of the bean. That's mainly is okay because we mechanically chew on the corn, we chew on the bean. But as far as okay as the skin of it is concerned, it's okay, it's mainly made up of cellulose. So it's okay, that's going to pass out undigested in your poop. Now, if you don't swallow it or if you don't chew it, what's going to happen? Well, okay, we don't have the chemicals that will have acted upon it as okay, we'll be able to just okay chemically break down the shell or the skin of a corn or of a bean. Usually, it's okay becomes a problem. It's okay in corns because they may just be small enough to pass undigested, and it's okay at some point. If you have it's okay this undigested corn here, come and block opening of the appendix. And that means okay, going to cause this okay, now the appendix can get inflamed. Or the patient may walk in with appendicitis. So guys, I have no problem you guys enjoying it's okay, your barbecues and corns and so on so, but just make sure that you chew well on the corns. Okay? If not, it's okay. You don't have the enzyme that's going to be able to just okay break down chemically, digest the or layer or covering of that corn or bean. And it may is okay just going to pass undigested through your gut. And well, okay. If it doesn't get stuck somewhere, then okay, that's okay. It will just pass out the other end. Any questions? So who has the enzyme to break down cellulose?
Animals?
Okay. Which animals? Now these were two, yes, okay, just two examples of things that we normally would eat, right? Okay, beans and corns.
A bird?
Not necessarily bird, man. Yeah. Cattles. What do cattle eat? Cow, sheep, goats. OMG.
Grass?
Corn?
Okay, grass. Good. So what do you find in grass? Cellulose. No, okay. Right. But they're able to digest it, and okay, as what do we get from that? Milkos. Okay, guys. Up. Now let's look. Now, ladies and gentlemen, what we mainly can say is okay, happens here. I mean, that's okay by the end of the foregut. By the end of the foregut. Okay, which was okay as at the end of okay that first 2/3 of your duodenum. We can mean this as okay, that's going to be the point where we can say the chemical digestion is completed. Okay, so at end of foregut, chemical digestion is completed. Which may mean that okay, there's not problem. There's mean that's okay going to be no more chemicals or substances just okay released into the alimentary canal beyond the foregut. Okay, we can even say as okay some 80% of the mechanical digestion is also completed. By the end of the foregut. Which may now mean, okay, what do we have left? We have the midgut. And yes, okay, we have the hindgut. Now, what did we have in the midgut? Well, okay, yes, just that. Last 1/3 of all duodenum. All of the jejunum. All of, yes, okay, the ileum. Just to stay within the small gut or small intestine right now. And as a matter of fact, okay, the remaining, yes, okay, first or the remaining 20% of the mechanical digestion made as okay is going to be as okay completed in the jejunal part.
I'm sorry, what is it after midgut?
Yeah,
It says last first of duodenum?
last 1/3 of the duodenum. I mentioned all these things yesterday. Last 1/3 of your duodenum, that was the midgut. Followed by the jejunum, followed by the ileum. Okay, right now we're just going to be focusing at okay as the small intestine part of your midgut. Okay. Now, guys, so once food is digested one way or the other, what was it digested into? When we say that food is digested, it is digested into
Is it the colon?
when food is digested, it is digested into what?
Nutrients.
Nutrients. And what was nutrients now going to be? or what do we want food to be digested into nutrients? What was the point of them being digested into nutrients?
To be absorbed?
To be absorbed. Okay, so when we say that, okay, as 90% plus minus of your digestion is already completed, what does that mean now? That the food is broken down into nutrients and mainly as, okay, is now ready to be absorbed. Did you guys get that?
Yeah.
Okay, so whatever you consumed, foods, liquids, etc., has been chemically 100%. 80% plus of it still is okay, mechanically is okay, digested, which mainly means that, okay, yes, a great amount of, okay, yes, the things that you ingested, put into your mouth now is being digested, broken down into the nutrients, which mainly means that they are ready to be absorbed. Okay, so what's going to happen? That absorption is mainly okay going to occur in the remaining of your alimentary canal. And what is the remaining of your alimentary canal? Your midgut and the hindgut. Okay. Where is it that the nutrients are going to be absorbed into? Primarily as okay into the bloodstream, because it's going to be the job of the blood to transport those nutrients to the, that's okay, organs, structures, etc., in the body that will need them. Did that make sense? Now, guys, please try to look here, okay? That's okay. You will find, that's okay, the same diagram here. That's okay in your book, figure 15.8. But we can mainly say, it's okay, that this is going to be, it's okay, a section of your small intestine. You may call it the ileum. You may say, it's okay, the jejunum. Okay. Now, first of all, it's okay, your remaining of the small intestine is not going to be as okay plain drainage passage like this. Okay, there you can as one says, okay, so you have this, or you have the wall of the small intestine and the wall of the small intestine. Or you mainly will see that, okay, that wall of the small intestine is thrown into these finger-like projections here that you see here. One is an example here. Or you can say, okay, one here, for instance. And they are going to be called the villi. Yeah, okay. So rather than being straight like this, the inline or the inner surface of your small intestine is going to be thrown into these finger-like projections called villi. Now, my first question will be, why? Why this and not this?
Is it to create more surface area?
Exactly. And more surface area is going to just, okay, cause greater exposure of the constants, because you can mean it says, okay, whatever you eat is going to just, okay, oh, that's okay, the broken nutrients also, that's okay, whatever you eat is going to just, okay, be running here, passing here. Okay. Now, please keep in mind, guys, that, okay, that these villi here is, okay, they are not going to be stationary. Okay. Which means, yes, okay, they're not going to be as, okay, standing still. But rather, this finger-like movement here, okay? Dancing like this. Clear? Okay. Now that's going to be, okay, we can say it's, okay, two purposes for that dance or movement of the villi. Okay. One is, well, okay, the villi themselves, yes, okay, increase the surface area. But mainly, yes, okay, also cause, okay, the constants within the gut that passes through the gut is me as, okay, moved over so that more and more and more as, okay, nutrients, because it is mainly as, okay, nutrients that will be passing. Okay, of course, there's going to be as, okay, some things which are not digested yet, mainly because, okay, we didn't have the enzymes, etc., or factors that was responded, okay, that were able to just, okay, digest those things. Okay. I mean, that's okay to turn it over and turn it, I may, okay, expose it to the villi. Clear? Okay. Another reason is going to be, is, okay, why they dance like this is to just, okay, complete that last part of, okay, what we call mechanical digestion. Okay. So as okay, we can say, okay, some substances, okay, which was still not just, okay, fully mechanically digested, get tumbled by the moving villi. That's okay, what? That's okay, be mechanically digested. Now, guys, one thing that we see is that inside the villi, I mean, that's okay, in the wall of your gut runs a blood vessel. We call him the artery. Okay. And that artery, meaning that's okay, is going to give off branch that's going to just, okay, run through the villi like this. Now, what we as, okay, may know is that, okay, what's going to happen is As it runs, becoming says, okay, nutrients are going to, yes, okay, be picked up by the villi and made, yes, okay, and into the bloodstream. Is that clear? Okay. And at some point, yes, okay, what that's okay, started its journey as an artery is going to, yes, okay, become a vein. Okay. But this blood in the vein, that's okay, this is going to be loaded with nutrients. Did you guys get that? Okay. Now, where these arteries come from and where these veins end up is something that we will talk, yes, okay, when we talk about, okay, the anatomy of the blood vessels. Now, ladies and gentlemen, if you guys recall that when we talk the lymphatic system, I said that it was going to be as okay, specific, or as okay, other kind of vessel, which we call as okay. This is going to be as okay, what we call the lacteal. Okay. And what was that going to absorb? As it's okay, it ran through, it's okay, the villi. Things such as lipids. Because, okay, this lipid here, I mean, it's okay, was going to be, okay, come a vital component of what we call lymph. Okay. Which means, it's okay, just becomes, it's okay, the lymph vessels. Now, since we say, it's okay, that these are, it's okay, the lymph vessels in the small intestine. Okay. Now, they mean that's okay, going to, it's okay, evolve like this. Sorry. Okay. And what we then is okay, we have in the peritoneum is going to be okay, those lymph nodes that we call the Myers patches. Okay. Did you guys get that?
Just to confirm, you said the lacteal vessel absorbs lipids in the villi and then goes out through the lymph vessel?
Yes.
Okay.
Okay. Now what these lipids made is okay, we're going to be is okay, they were going to be is okay, a vital component of what we call lymph. What was lymph? The fluid that ran through the lymph vessels. Did that make sense? Okay. So when we talk the lymphatic system, and I say it's okay, the lacteal vessels, well, okay. So that's okay. Every villi is going to have them. Okay. In some cases, okay, they just cut up. Yeah, you see, it's okay. Everything. You have an artery coming in, and as it leaves, that's okay, it's going to be referred to as a vein. You also have okay as a lacteal. It's written right here. Lacteal, which means it's okay, it just becomes a lymph vessel. Or you can say, okay, the lacteal is the lymph vessel that runs in the villi. Okay. Which means that's okay, it's going to, that's okay, prime, that's okay. Gets, it's okay, the substances that is okay, yes, are being absorbed from the gut that is going to yes, okay, play a vital role in the formation of lymph, which mainly yes, okay, was lipids.
Could you
Did
just
you guys-
scroll down a second, just so I could see what you wrote down for the lymph vessels?
Well,
Thank
okay,
you.
what the lymph vessels become, yes, okay, they remain, yes, okay, run, and okay, yes, we had those groups of lymph nodes in the peritoneum that made us, okay, receive lymph vessels from the small intestine, and those group of lymph nodes are what we call the Peyer's patches.
Thank you.
No problem there. Yeah, okay. So, guys, what we mainly as okay can say for this part here is that as food, or as okay, let's say it's okay, substances passes through the remaining of the small intestine, they are 90% plus already as okay digested, which mainly as okay just made them ready for absorption, primarily as okay into the bloodstream. Did you guys get that? Did you guys get that? Okay, guys. Now, my teacher in physiology, or let me put it this way, yes, okay, my teacher who taught me physiology of the digestive system gave us a formula or gave us a statement that pretty much, okay, yes, simplified the absorption part of your digestive system. And what I like to do is just convey the message ahead. So what did he say? He said, and I'm going to say it, that we eat through the small intestine. Okay. And we drink through the large intestine. Now, what would that mean? Now, usually, guys, it's okay when we say eat. That's related to the food, right? Clear? Okay. So what he meant by saying is okay that we eat through the small intestine. That mainly means that okay, as whatever we consumed in or consumed in form of food has been digested, and mainly as okay is going to be as okay. So the nutrients that we get from as okay whatever we eat, bread, meat, potatoes, you name it, right? Okay, vegetables, corns, grains, etc., etc. When they are as okay digested, okay, the substance, that's okay, the nutrients derived from that, that's going to mean is okay, be absorbed as it passed through the small intestine. Did that make sense? Where, okay, when he said, okay, that we drink through the large intestine, you can mean it says, okay, whatever fluids we consumed. Okay. Water. Okay. Even as, okay, milk. Okay. A good, great portion of the milk is still water. Yeah, okay. But most IS, okay, the common fluid to be consumed is going to be water. So all liquids that we consume, okay, now they are primarily as okay going to be absorbed as their contents pass through the large intestine. Now normally as okay we say it's okay 80% of milk is water. There may be places where it's okay milk is more than 80% of water, right? If so,
Yes.
why?
Well, in Pakistan, they drink a lot of milk. Like, there's just cows everywhere.
Okay, but where? Where do you find that, okay, there's a lot of, it's okay, more than the normal percentage of the milk is water?
Would it be the village?
Okay, why am I asking you out of all the students? Why am I asking you?
I'm not sure.
You're not sure? Okay,
No.
okay. What do people usually do with milk in Pakistan? The people who sell it.
They go door by door, I know. And I
Okay,
know boil the milk also, but I don't know
okay.
if that.
But it's okay, the cow only gave them, it's okay, 5 gallons of milk.
Mhm.
And they still be able to sell 20 gallons of milk. How in the hell is that possible?
They cheat it, they add water to it.
They add water to it. Here we go. Okay. Now, I'm not going to say it's okay where they get that water from. But once what happened was that a guy, he found a fish in his milk. He found a fish in his milk. And the next day when the guy came to his door, as Hifsa just says, okay, they walked door by door. He said, well, okay, I found a fish in my milk. Can you explain how that ended up, or I ended up having a fish in my milk? And this milkman is okay, scratches his hands. Okay, now how in the hell do I explain this? And he said, well, okay, of course, the cow has to drink milk. So what might have happened, okay, as Eddie, no, so not drink milk, sorry, water. So Eddie was drinking water from a stream or a river or whatsoever. It may have swallowed a fish. And that fish came out in the milk. That's how yes, okay, it ended up with you. Okay. But yes. So okay, dear. Yeah. So literally, guys, what is going to be absorbed in the large intestine? Liquids that we consumed. Okay. Now just think of it this way, because first, came the small intestine. Okay, okay. The constant in the small intestine is like a paste. Okay, a thin paste. Let's put it this way: a thin paste. Okay. Now, what mainly is okay, the nutrients is going to be absorbed from that as it passes through the small intestine. So the contents of your gut become, yes, okay, less paste, like a more liquidy. Okay. So as it goes from the small intestine into the large intestine, it's pretty much okay, it's a very liquidy content. Thin in consistency. Okay. Now it's going to be, yes, okay, the job of the large intestine, or the colon, as we may call it, to absorb the fluids from that as it passes through the large intestine. Now, what's going to happen to the content? It's going to become less and less liquidy. And as it passes through, it's going to become more and more and more and more, less and less liquidy, or more and more solid. And eventually it's okay, become, yes, okay, into the consistency that we know as poop that comes out at the other end. Did that make any sense?
Yeah.
Good. Now, what did I say the other day, Asma?
About what?
About what?
You said a lot of things.
Okay, I say a lot of things. Okay, good. Sorry. Now, that God said we created man in his best form. Now, just switch the function of the colon and intestine, or small intestine, and say, had it been the other way around, that the liquids would have been absorbed in the small intestine. By the time it reaches to, yes, okay, what would have been the colon, which might have been, yes, okay, then yes, okay, used to absorb the nutrients, it would already have been hard. So yes, okay, that was going to be, yes, okay, a pretty painful journey for the person as that conscious, okay, passed through the colon, right?
True.
True. Good. So pretty much, okay, as the contents pass through the colon, or main is, okay, is going to be absorbed from it, from the contents that runs through the colon or large intestine, is going to be fluids. Okay. Now the way that it works is, that's okay, that along with those fluids, that's okay, that fluid is also, that's okay, going to pull some salts, some minerals, even, that's okay, some sugars, and so on. So, but mainly, that's okay, as we talk about, it's okay, what is going to be absorbed through the colon is going to be fluids. Okay. So we can say, okay, that was pretty much okay as the function of your, I mean, it's okay, the part of absorption. So, but if you remember that we eat through the small intestine and we drink through the large, mainly explains what is going to be absorbed, mainly, as the contents pass through the small intestine. Mainly as, okay, the nutrients that were derived from the food that we ate. Okay. Where, okay, as the contents pass through the large intestine, what's going to be absorbed at that part? mainly as okay the liquids that we consumed. Which mainly called that okay as at the other end. Of course, that's going to be as okay substances that we ate that didn't get digested. Either because yes, okay, well, okay, they are not considered to be nutrients, but they're still a part of your food. I gave an example, cellulose. Okay. Great. Fibers. They are not nutrients, but we still eat them because they are good for the gut health, if that's what you want to call it. Okay. Otherwise, that's okay. They don't really have much of a nutritious value. You're not going to, as okay, be able to absorb that, as okay, fibers into your blood. Why? Because we don't have, as okay, the ability to digest it. Okay, so you can mainly say, okay, anything that remains undigested. Okay, anything that you consume that remains undigested is going to remain unabsorbed. Did that make sense? Okay. So things that you consume which doesn't come as okay, which are not digested, which mainly mean that they will not become nutrients, cannot be absorbed. And what cannot be absorbed is going to be pooped out in what you call feces. Okay. What that means is okay is going to be as okay removal of undigested, unabsorbed contents of the gut is what we mainly as okay will call elimination. Okay. Or let's put it this way, that actually is okay is a more okay, yes. I don't know what to call it, but we can say it's okay term for passing out pieces is going to be defecation.
Does that say passing out feces?
Yes.
Thank you.
Okay. You may use another word, which is shitting. Okay, not in your papers. Okay. Okay. So what was okay? Different names of different procedures that we talked about. First was chewing. We call chewing mastication. Then we said swallowing. What did we call swallowing? Deglutition. Right? Okay. Then we say as okay, passing out feces or pooping or whatever you want to call it. Yes, okay. An official term for that or a technical term for that is going to be defecation. Did you guys get us that? Okay, guys, just take a short 10 minutes break. And I see you guys back. And then we will talk a bit about yes, okay, the anatomy of the large intestine. Okay?
Thank you.
No problem. So I see you guys at 11:05. Okay, guys, welcome back. Okay, guys. So we can say it's okay, the large intestine. Or what we also call the colon. Okay. Now what we already said is we had the stomach. We had the first part of the small intestine that we call the duodenum. Pretty much okay, followed by loops and loops and loops and loops of jejunum. Followed by loops and loops and loops of ileum, which is going to just okay meet with the first part of the gut colon, which is going to be the cecum. So we can mainly say that, okay, yes, the large colon or the large intestine or the colon, okay, is going to just, okay, what does it do? It receives the ileum weight, okay, at, well, okay, this point here, known as the ileo, from the ileum cecal, from the cecum junction. Okay, so pretty much, okay, the point at which the ileum, yes, okay, empties, or yes, okay, meets the cecum is going to be referred to as the ileocecal junction. Okay, now guys, if we look at the ileum and we see the cecum. Okay, so this junction point here is okay. Oh, let's just do this. Point where they meet is going to be, okay, called ileocecal junction. Okay, and this ileocecal junction is guarded by a sphincter. So at this point of the ileocecal junction, yes, okay, what is that we're going to have? we're going to have a sphincter. And that sphincter is just going to be called nothing more but the ileocecal sphincter. Is that clear? Okay, and what did we say that a sphincter was? Okay, or mean the form of the sphincter mean that's okay, was just a thickening of the circular muscles in the wall of the intestine. Right? That means it's okay, makes this. They have like mechanism between, in this case, as like between the ileum and the cecum, or between the small intestine and the large intestine. Which means it's okay, what we call the ileocecal sphincter. Did you guys get that? Okay.
So is the sphincter where they open as well?
Yes, my dear. It will
Okay.
open when you want contents from the ileum to pass into the cecum, right? And close. Or more like this. Open, close. Open, close. Because what was it that was made up of? The circular muscles in the wall of the intestine. Okay. You just have more layers of those circular muscles. Okay, and what are they going to do? They're going to just, okay, produce a thicker ring around that part of the intestine, which means it's okay, but when that relaxes, it opens up. When it contracts, it closes. Did that make sense? So here's, okay, no fancy name. Well, okay, none of our sphincters yet have had any fancy names. This is just called, it's okay. Or named after, that's okay, where it is, that's okay. Named after the two structures that it lies in between. Okay, so it means it's okay between the ileum and the cecum. So that's why they call it the ileocecal sphincter. Okay. But the passage in the ileocecal sphincter, okay, is okay, narrow down. And okay, the passage can open up. All dependent upon is okay whether these circular muscles here is okay, were contracted or relaxed. And anatomically, yes, okay, where would you find this whole thing here? Yes, okay, that's going to be in the right iliac region. Now, something that I already mentioned, that's okay, that what you also will find in this area here is going to be, is okay, the appendix. Okay, so the appendix mainly, yes, okay, is going to, yes, okay, be attached to, yes, okay, this lower end of the cecum. Yeah. Now, guys, one thing that I mentioned yesterday, and I say is okay, throughout the entire gut, or we can say it's okay, alimentary canal, when it came to, yes, okay, the arrangement of the muscles, we mainly said, okay, yes, that the circular muscles are deeper. So if your says, okay, say, okay, this is a cross section of any part of your alimentary canal. We can say, okay, this here is okay, is the passage through which, okay, the consonants will pass. And we talk about is, okay, the muscles, the circular muscles are going to be deeper. Why do we call them circular muscle? Mainly because, okay, the muscle fibers runs like this. There, on the other hand, because that's okay, the other kind of muscles, which was what we call the longitudinal muscles. That's okay. Are at a shallower depth or a lesser depth. Or more literally, that's okay, more close to the surface. And why do we call them longitudinal? Yes, okay, we look at, okay, as the extent of a part of intestine, yes, okay, passing. These muscle fibers mainly, yes, okay, are going to run like this. Along the course of your intestine or alimentary canal. Whereas, okay, deeper to these, as okay, was going to be as okay, the circular muscles, which means as okay, was circular because they circled around. In front, and we can say, okay, the back. Or, as I said, if this was okay as your intestine, this will be the arrangement of your circular muscles. And this will be the arrangement of your longitudinal muscles. Okay. But where the circular muscles will be deeper down, the longitudinal muscles would be more, yes, okay, towards the surface. Now, why did I felt the need to, yes, okay, repeat this? Because, guys, if we look at the colon, and let's just say it's okay, you take any part of the colon. Let's say it's okay, we have the cecum here. This is our cecum. Now, after that is okay, what is it that we will have? Here's okay, the first part of the colon. Now, whether it was the small intestine, that's okay, most of your, okay, all of your small intestine, the comenius is okay, the longitudinal muscles would be as okay running, or be evenly as okay distributed throughout as okay the whole area of the small intestine. The arrangement of your longitudinal muscle is going to be as okay a little bit different when it comes to the large intestine, because the mainly as okay is going to be as okay arranged in three. Okay, I mean it's okay, that's okay. And then just okay around like this. Three lines. Okay. Like this. Oh, we can say it's okay. Let's put this one here. It's okay. So one more VS okay on the posterior surface. And what, okay. And actually, that's okay. If you look at the surface of the colon, if you open the abdomen and okay, yes, look at the colon, you actually, yes, okay, will see, yes, okay, the longitudinal muscles on the surface of the colon. Yes. And what do they call them? Yes, okay, for the colon? The arrangement of your longitudinal muscles into these three strips here. Yes, okay, that's actually going to be referred to as the tinea coli. Now, coli here is okay, mainly is okay, we can say because it is related to the colon. Now, the word tinea, Tinea, actually is okay, is a word that means worm. Okay, so this doesn't mean okay as that you're talking about as okay worms in the intestine or the colon. But mainly okay, the reason that they call them Tinea coli is mainly because okay when you look at okay as what the longitudinal muscles may look like, they look like as it's worms running on the surface of your colon. Is that clear?
So the tinea coli is just
Yes,
the
my dear.
arrangement of the longitudinal
Exactly,
muscle.
exactly, exactly. Let's see, maybe we can find. Where is he? Okay, guys. Let me just share this picture and show you what I'm talking about. Okay. So I hope all of you is okay will agree that this was the stomach, this is the liver, this is the gallbladder, this is the duodenum. We can make this as okay, yes, okay. This would be as okay loops of jejunum, then we have okay loops of ileum that enters into yes, okay, the cecum. Here we have the appendix. And this is what's going to be as okay, your ascending colon, the transverse colon, descending colon, sigmoid colon, rectum, anal canal, and anus. Okay. But let's just okay, yes, magnify that a little bit more. And ladies and the gentlemen, what do you see here? Okay, this is okay. This one says okay, is the segment of your colon. This yellow thing here, this thing that is marked yellow here, or even it's okay, mark yellow here, or even it's okay, mark yellow here, is mainly as okay, just your longitudinal muscle. Okay. And it mainly as okay, runs like okay, as a big or smaller, or it looks like as okay, so big or smaller worm, that's okay, running along the course of your large intestine. Okay, so this is mean that's okay, what we just call the Tinea coli. Okay, guys, just give me a second. Did you guys get that? So the Taenia coli is nothing more but mainly as okay, just the name for your longitudinal muscles in the large intestine. Okay, which unlike as okay, your other parts of just okay, your alimentary canal, whether that was the stomach, esophagus, small intestine, where that was the duodenum, jejunum, ileum, okay, was distributed all throughout, all around. Was going to be longitudinal muscles. In your large intestine or in the colon, the longitudinal muscles are limited to just 3 strips. Track, track, track. Did that make sense? Okay. And. Very much, guys. If you see us, okay, we have 1 strip of Taenia coli here. Yes, okay, we have 1 strip of the Taenia coli here. And we're going to use as, okay, a strip of the Taenia coli here. Where these 3 is okay meet. That's going to be as okay, be the base of the appendix. Okay. So sometime, yes, okay, when we had, okay, yes, hard time, yes, okay, locating, yes, okay, where the appendix was. Okay. Yes, okay, because in my head, okay, has made a U-turn and okay, has be lying behind the cecum. It made us okay, will just follow us, okay, one of the Taenia coli. That's okay, oh, well, boom. It's going to be okay somewhere here. And okay, let's fish it out if you want to put it that way. Okay. Now, guys. So if this is the person, let me guess it. Okay, this is the right side. This is the left side. Okay. We said we had the cecum. Okay. After that, we have the colon, which mainly is okay, goes up. And saying that's okay, the part of the colon that goes up, mainly that's okay from your right iliac region through the right lumbar region into the right hypochondriac region. But mainly it's okay because it is going up. We call that the ascending colon. Now, guys, what we mainly as okay come across in this area here is going to be the liver. Okay, and pretty much okay as close by as okay the liver. That's going to be as okay where your ascending colon is mainly as okay going to make a turn. And go on like this. And mainly as okay because it runs across. That's why we will call it the transverse colon. Okay. But this point here is okay, where we mainly say that, okay, as the ascending colon turns to become the transverse colon, this point here actually is okay, can be referred to as the hepatic. Now, why hepatic mainly is okay, because it occurs at the liver. Hepatic what? Next. Okay. So pretty much okay, the part of the colon where the ascending colon becomes the transverse colon is going to be referred to as the hepatic flexure. Okay. Now, what the transverse colon means does do is, okay, as it goes from right to left. What we may as okay having, let's say, it's okay, this area here. It's okay, it's going to, let's say, it's okay, the stomach. Ultimately, yes, okay, at some point on the left side, is it that okay, your transverse colon is going to, yes, okay, make a turn and start to go down on the left side. And since it is going down, yes, okay, that's why we call it the descending colon. Did you guys get that?
Yeah.
But what else do we see is that, okay, just like, okay, as it made a turn by the liver that we call the hepatic flexure, it also just makes a similar turn over here. Okay, pretty much, okay, it's a little bit past the stomach. And this flexure here is meaning it's okay, it's still going to see it's okay, we call a flexure. But it's okay, named after what? Named after, it's okay, a structure that we had behind the stomach on the left side, which was the spleen. So this flexure here is going to be called the splenic flexure. Okay. What happens at the splenic flexure? Yes, okay, the transverse colon makes a turn and actually, yes, okay, it starts to go down. Did you guys get that? Okay, so since that's okay, it is going down, we call it the descending colon. Oops. Or if you look it on Mr. here. So right side, left side. Right iliac fossa, where the ilium meets the cecum, we have the ascending colon. Yeah, okay. We can say hepatic flexure, after which we have the transverse colon. After which splenic flexure, and Emilius, okay, goes down as the descending colon. Now, after which it means that's okay, will start to turn medially. That's going to be a little bit hard to, it's okay, displayed here, but actually it's okay. This part is okay, it's going to be right in front of the sacrum. But this whole thing is okay, mean it's okay, has a shape that looks like an S. Okay. So we can mainly say it's okay. Okay, let's shoot this. Something, and since it has this S-like structure, that's why it's okay, they call it the sigmoid. Some people will call it a sigmoid. Some people may even go and say it's okay, the sigmoid colon. All words are correct. Okay, but this pretty much okay is going to just okay run. It's okay, right in front of the sacrum. Is that clear there? Now, what do we have after that? Now, let's just say it's okay. This is okay, yes, the sigmoid. After that, maybe it's okay, comes what we will call the, I'm running out of colors here. Okay. Rectum, which mainly is okay, leads into this okay, smaller structure called the anal canal, which mainly is okay. A pair of sphincters. Now that's going to be as okay, or we can call the internal anal sphincter. And pretty much okay, yes. We're going to say this okay, this opening here is okay, which we'll call the anus, which is going to be guarded by another sphincter called the external. Okay, sorry. Sphincter. And of course, that's okay, that's going to be another sphincter. Did you guys get that? So your anus, if that's what you want to call it, actually, so it's going to just okay be guarded with not just one but two sphincters. The internal anal sphincter and the external anal sphincter. Do you guys mind if I go to another slide?
No.
So we can say it's okay. If this was as okay, the anal canal. Okay. We had an internal anal sphincter. And pretty much occurs at the opening. Right through. Yes. At the opening of the anus. Yes, okay, that was going to be guarded by this sphincter here, which will be the external anal sphincter. Did you guys get that? Now, guys, what I really just want to emphasize on here is that this internal anal sphincter here. So you can say, okay, what makes it a sphincter? Maybe it's okay because it is a ring. Okay, pretty much made of, okay, yes, the circular muscles in this case, it's okay, anal canal. Okay. Did that make sense? That we made the says, okay, that these circular muscles here in the anal canal still were smooth muscles. And what have we said about smooth muscles? What have you said about smooth muscles?
They're involuntary
They're involuntary, so they are not under your
control.
control. Okay, guys. Now you may say, Mike, that is none of your business. But have any of you ever experienced that, okay, you are just about to, yes, okay, sorry for the words, in your pants? That the pressure is building up pretty badly and you say, okay, okay, but right now it's okay. There's only it's okay 10, 15 yards for me to run to the closest restroom. That's pretty much okay because it's okay that internal anal sphincter already has relaxed. But what mainly is okay keeps you from, yes, okay, not you, or keeps us, let's include myself in this. Well, it's okay. Shitting in your pants is because of the external anal sphincter. Did that make sense? So what did that tell us? Well, okay, that this has to be okay, something that we'll be able to control, right? Or for our instance, okay, it's okay, hold tight. Okay, now still going to be okay, circular muscles. But these circular muscles here, yes, okay, mainly are going to be skeletal muscles. Yeah, okay. Pretty much okay, is coming from, yes, okay, the skeletal muscles that plays a part in the formation of the floor of your pelvic outlet. And why they're going to be as okay, skeletal muscle? Well, okay, yes, okay, they're probably not going to be attached to a bone, but at the other end, there's going to be as okay, some sort of bone to which they will be attached. But the main is okay, here around the yes, okay, anus arranges in okay, in a circular manner that forms the external anal sphincter. But it's okay, made up of skeletal muscles. And that's why it's okay. You may be able to, yes, okay. Okay. Let me just time this, yes, okay. So that I'll be able to make it to the restroom and, okay. Then, okay, yes, you sit down, okay, okay. Everything's come out. Did that make sense? So, yep. Thanks a lot for that. Okay. Now, does anybody have any questions?
So the external anus sphincter is a skeletal muscle and the internal one is a smooth muscle.
Which means it makes, okay, smooth muscle, not in our direct control, right? Okay. It's probably as okay, just going to give up under pressure. Clear? Okay. The external anus sphincter, skeletal muscle, mainly because, okay, what forms that is made as, okay, muscle that we have in the floor of our pelvis. Or we can say, okay, the perineum. Okay. The floor of your pelvis or pelvic outlet, if that's what you call it, is going to be referred to as the perineum. But what is that made up of? That's, okay, some very strong muscles that, okay, makes up that floor. Okay. There are going to be as, okay, openings because, of course, as, okay, one opening is going to be as, okay, the anus. Okay. Okay. There's going to be as, okay, another opening is, okay, through which is, okay, the urethra will open. Okay. And for women, yes, okay, there's going to be an opening to, yes, okay, for the vagina, or it's okay, what we also call the birth canal. But otherwise, that's okay. So, any questions, guys? Okay. So, as far as the colon was concerned, we could say we had the cecum, we had the ascending colon, we had the transverse colon, we had the descending colon, we had the sigmoid colon or sigmoid. Clear? Okay. Area, sorry, the area where the ascending colon becomes the transverse colon is known as the hepatic flexure because it makes a turn right there by the liver. Okay. The part where the transverse colon becomes the descending colon is going to be the splenic flexure. Why being is okay is going to be as okay in the proximity of the spleen. Did you guys get that? Did you guys get that?
Yes.
After yes, okay, sigmoid, what do we have? Rectum. After rectum, do we have anal canal? After anal canal is opening through which undigested, since undigested, unabsorbed, contents of the alimentary canal is going to be passed out, which was the last function of the digestive system, which we call elimination. But the process of passing of stools or feces or S-hit is what you call defecation. Clear? Did that make sense? So the process of, sorry, Maria, the process of pooping or passing feces is defecation. Yes, you had a question, Vicky?
Oh, I was just going to ask if you could write all that down, like the elimination, like all that.
Elimination is just what we say also about the last function. I said we had 4 functions of our digestive system, right? Okay. First was ingestion. Ingestion. What was that? Me see cookie like Cookie Monster like cookie. That was ingestion. After that, digestion. Chemical digestion, mechanical digestion. But digestion. After that, what did we have? Once food or once anything ingested was digested, what did that mean? It was converted from that ingested form into the nutrients. And when we say nutrients, what does that mean? That they were broken down into a form that now was absorbable, to be absorbed through as okay the wall of your intestines, pretty much okay to be picked up by the blood in the intestines. Okay, so that was absorption. Whatever contents of your alimentary canal as it passes as okay through the entire course remain unabsorbed. Okay, there may be as okay even substances that's going to be as okay, you can say secreted into your gut or released into your gut. Okay, that may as okay just follow the constants or okay flow along with the constants of the gut and not get, you can say, okay, absorbed. Any yes okay substance which is unabsorbed, well, okay, you know your body is not going to be accumulating on it. It's just going to say, well, okay, listen, okay, due to whatever reason, that's okay, you are not absorbed, we can't keep you anymore, out, exit. So that exiting was the last process of the digestive or function of the digestive system, which means as okay, we just call elimination. So elimination is going to be as okay, we can say it's okay, getting rid of the, in this case, it's okay, unabsorbed contents of the alimentary canal or gut. Okay, the process is what you call defecation, passing poop or passing stools. Okay, so that's where okay things such as okay as your sympathetic, parasympathetic nervous system, somatic nervous system, those things comes in. Okay, what are under your control, what are not under your control. But we're not going to go into all those details. But as I say, yes, okay, I just want you guys to realize that okay, yes, be thankful for having yes, okay, a functioning external anal sphincter. Otherwise, yeah, okay, you would know what would happen. Okay.
I had a quick question.
Yes.
I know you mentioned the circular and longitudinal muscles.
Mhm.
Are the oblique muscles also found in the small and large intestines?
No. That's why I mentioned it in the stomach, my dear.
Okay, just
That the
making sure.
stomach was the only organ where we not just had 2, but actually it's okay, 3 arrangements of muscles. Clear? Okay, where this oblique is going to be as okay the inner, then circular is going to be middle, and longitudinal is going to be outer.
Okay.
Did that make sense?
Yes, thank you.
Okay, just like okay, if you compare these 2 fingers, here we had 3 phalanges, right? We call one proximal, then we said middle, and then distal. Whereas in the thumb, we only had 2 phalanges, right? Proximal and distal. Did that make sense?
Yeah,
Okay.
thank you.
So throughout the gut, what you will find throughout the gut was longitudinal and circular. It was only going to be in the stomach that we had, okay, a third arrangement of the muscles, which was going to be oblique. Where you can say, okay, this is longitudinal, this is circular, and this would be oblique. So circular, longitudinal, and oblique. But that's only found in the stomach. Otherwise, throughout the other parts of the alimentary canal, deeper, circular, more towards the surface, so longitudinal.
Thank
Did
you.
you guys get that? Yes, guys.
Yes.
Any questions? Okay, ladies and gentlemen, just take your lunch break. Make sure that you masticate the food before you deglutate it. And when we come back, yes, okay, we can talk about, yes, okay, our biggest gland in the body known as Mr. Liver. And okay, when we talk of liver, yes, okay, we just get a little bit closer to, yes, okay, the gallbladder as well. And talk a bit about that one, okay? Did that make sense?
Yes.
Okay, guys. So I see you guys, should I say 12:50.
Sounds good. Thank you.
Okay, take care. Good. Good. Mamma mia. Now, guys, let's just briefly talk of the pancreas. Okay, just so we know what the blue we're talking of. If this maybe a little bit too high. If you say this was the stomach, this was the duodenum, and this would be the pancreas. Now, what I said earlier was pancreas was both endocrine because it produces insulin and what we can call glucagon. It was also exocrine, primarily because it produced, and that's going to be the major one that we will talk about. amylase. It also produces, okay, what we call lipase. It also produces, okay, what we call nuclease. Okay. If we talk about it, okay, its anatomy. Okay. Head of the pancreas. Is located on the medial side of the, as is, okay, loop of duodenum on the medial side of this loop, or let's say it's okay. Let's rephrase it there, okay, that C-shaped loop of the duodenum. Okay, where as you can see, the body and tail of the duodenum of pancreas, sorry. That's okay. Runs posterior to the stomach. That's why it's okay. I dotted it out. Okay. Now, as a whole, the pancreas is retroperitoneal. Which may mean whether it is the head, the body, or the tail of the pancreas, all of that is going to be retroperitoneal, which may mean that only the anterior surface of the pancreas, okay, is covered by peritoneum. So if you may, it's okay, take a sideways views. Now we can say, okay, if this, for instance, okay, here was the stomach. We can mainly say, okay, this part here will be as okay, yes, okay, the pancreas. Okay, so this was the pancreas. And this part here is okay, that was the stomach. And we can say, okay, this is anterior and posterior. Okay. Now we already know that, okay, as peritoneum is okay, come from the liver, runs anterior to the stomach, okay, like this. At the lower boundary of the stomach, it was going to, yes, okay, continue on as the greater omentum. Meaning, yes, okay, running back, and then here, now your peritoneum comes and runs like this. Okay. On the other surface of the stomach, or we can say that on the medial surface of the stomach. Well, okay, yes. What was peritoneum that came here? And what is peritoneum is going to come here? That is going to form it, okay, what would be the lesser omentum. Okay. That's going to just run up the back side of the liver. And then run down like this. So that's okay. What that comes out of it, it's going to run down like this. But even then, all of your pancreas is going to be behind the peritoneum, which makes it become retroperitoneal. But it's only going to be the anterior surface of your pancreas that will have peritoneum running off. Okay. But the pancreas as a whole is not going to be covered up by peritoneum. Did you guys get that? Yes, guys.
Yes.
Now another thing. So can we say that the stomach? We said duodenum. We said that yes, we have the pancreas. And what the pancreas had was what we call as the pancreatic duct. Okay. Now, mainly what was going to be released by the pancreatic duct will end up in the will be secretions that end up in the duodenum. Okay. Now the main one that I want to talk about here is going to be amylase. So he says, one of the secretions produced by the pancreas was an enzyme called amylase. Okay. Now, those of you who are DMS, I've never seen it. It can happen for anybody. Yes, may come across patients who comes in with what they call pancreatitis. Now, if you just look at the word pancreatitis, what does that be? Inflammation of the pancreas. Okay. Now we can always talk about the reasons for these. All this, the common reason for it is alcohol. Okay. Are most of the common reasons for pancreatitis or acute pancreatitis as the makeup of it? Or usually it happens suddenly. It's alcohol. Okay. What mainly happens is yes, the pancreas becomes inflamed. Okay. And what that mainly causes is that mainly there will be some constriction due to in inflammation, because one of the things that happens in inflammation is swelling. So the patient may will come with this pain pretty much as epigastric pain. So it's a question, is this a bleeding test? Is this a bad stomach ulcer or what? Is this a heart attack? So and so. One thing that they may do to confirm one or the other is that they take as a blood amylase level. And if that is high in the blood, that mainly confirms that this is pancreatitis. Okay. And some of you say, okay, but how does amylase ends up in the blood? Mainly because of, okay, yes, because there's, okay, a backflow of the amylase, which was produced by the glands. But then it's okay, since it can't go into the duct, it may, it's okay, backflow into the bloodstream from the glands. Now, besides alcohol being, it's okay, a common reason for pancreatitis, it can also be stones. Okay. Now, we usually only hear of kidney stones, or bladder stones, or ureter stones, or gallstones. So this stone here, or stones, could be gallstones. And why is that? Now, as I told you guys earlier, it's okay, this area is okay where the that's okay, sorry, bile duct and okay, your pancreatic duct empties into the, or enters, or is okay, secrete their secretions into the duodenum, may be as okay an area of okay as anatomical differences from people to from person to person to person. So in some persons, that's okay. In some people, that's okay. What we may have is that duct that we call the common bile duct may open into the pancreatic duct, and that's okay. Through that, it's okay. That's going to be it's okay where the bile and okay, some liver enzymes and so on. So it's going to be released into the system. May come, but this is also going to be it's okay. What may get gallstones, and they may block, and hence the same thing as we said earlier. Well, the amylase is not able to make it out, and so on. So yeah, okay. So we still say, okay, yes, it is still pancreatitis. It just comes, okay, what caused it. Okay. Usually that's okay, running liver tests on a person will confirm that, okay, he or she, is usually he, has been or is a heavy drinker. Some off, yes, okay, numbers, okay, liver tests. Did you guys get that? Okay. So yes, okay, a condition that you guys may, yes, okay, come across, and strangely enough, yes, okay, you may find, yes, okay, gallstone that pretty much, okay, have gone all the way down from the gallbladder through the duct, and okay, just somehow, yes, okay, got stuck. Did any of this make any sense?
Yes.
I have a question.
Yes.
Um,
Who am I
So-
talking?
me, Justine.
Okay.
Hi.
Right.
Okay, so the pancreas head, is that posterior as well, did you say? Or no?
Posterior to what?
The stomach.
No.
Okay, but the body is posterior to the stomach.
Body and the tail is going to be posterior. The
Okay,
head of the
but-
pancreas, no, the head of the pancreas, my dear, if this is your duodenum, the head main, yes, okay, just fits into that loop formed by, yes, okay, the C-shaped duodenum. Did that make sense?
Yes, but the whole pancreas is covered by the peritoneum, right?
No,
the whole.
Nope.
Oh.
All of your pancreas is going to be retroperitoneal.
Just the interior surface is covered by the
Exactly.
peritoneum?
So it falls behind the peritoneum, right?
Yes.
Okay, that's what you mean.
Okay.
So that makes it retroperitoneal. Did that answer your questions, dear?
Yes.
Okay, good. Another condition that, okay, yes, may affect the pancreas is what we call pancreatic cancer, or cancer of the pancreas, whichever way you want to put it. And it may sound strange, but this is extremely malignant. Usually it's okay where we see that, okay, once somebody is diagnosed with this, it's pretty much, okay, yes, a rapid decline. Do you guys remember an actor? Now, some of you may even not have been born when he was dying. Huh? Yes, Vicky, you said his name?
I thought I was on mute. I said Patrick Swayze.
Exactly. Okay. Although as okay, he managed to as okay be alive for okay as a relatively longer period, but it's okay at the end he was pretty much okay, just a walking skeleton. Okay, so so that's okay, extremely deadly, and well, okay, unfortunately, it's okay. By the time that it ends up getting diagnosed, it may already be too late. Not that there is any much, it's okay, any cure or treatment for it, because it is a relatively rare cancer. She says, okay, you have a smaller population group. There's going to be okay a smaller availability of. You can say it's okay. Should I use the word guinea pigs? Who wants to yes okay be used to yes okay come as okay help in determining or finding a treatment for it. But yes okay, unfortunately it's okay a deadly cancer of the pancreas. Okay, guys, let's just talk a bit about Mr. Liver.
Wait, I have a quick question before
Yes,
you
my
go
dear.
on.
I'm
You
still here, dear.
It's Michelle, and quick question.
Okay, I'm still here. You said before I go, I'm not going anywhere.
No, before you go onto the liver.
Okay, good. Go ahead, dear.
I couldn't understand how you said something about the gallstones being formed.
Oh, I didn't talk about the gallstones yet. We're not even.
Oh, okay. So all you talked about was the pancreatitis being an inflammation, right? Of
Mhm. Exactly.
and it's due to like alcohol or whatever.
Yeah. Common reason is that most reason is alcohol. Okay. Some cases, okay, it may be because it's okay, a gallstone got stuck in the pancreatic duct.
Oh, okay.
Clear? Okay.
Thank you.
No problem with it. Because what I said earlier, and I repeated myself, is that okay, this area here is okay around the gallbladder, your pancreas, or let's say okay, the pancreatic duct and all that, and okay, it's your bile ducts and hepatic duct and cystic duct is going to be as okay area that's going to as okay vary from person to person to person to person. Okay, so that's an area of okay, or you can call as okay some slight, yes, okay, anatomical variations. Okay, but here we may, yes, okay, just talking about, yes, okay, the most common, yes, okay, way in which, okay, yes, the structures are arranged. Okay, yep. Now next is Mr. Liver. Now liver, first of all, is the largest, gland of the body. So out of all the glands that you have in the body, the liver is the largest. Okay. As far as, okay, yes, functions of the livers are concerned, if we talk about, yes, okay, what the functions of the livers is, or liver is, okay. Now, its main function is going to be metabolism. Did that make sense? Okay. So most of the metabolism that's going to be, yes, okay, be performed by your body is going to be performed by the liver. Clear? Okay. Did that make sense? Okay. Now, roughly, as okay, just talk about is okay, just to mention a few things that okay is will be metabolized by the liver. First is going to be as okay nutrients. Now the question is okay, where does these nutrients come from? These were yes okay mainly absorbed from your intestine. Clear? Okay. All right. Through the blood. And what the blood mainly as okay will do is before as okay those nutrients can be as okay delivered out into the body. They will first make a trip through the liver. Mainly as okay to undergo as okay metabolism. Now this metabolism here is okay can be breakdown, which was catabolism, or it could be makeup, which was anabolism. Okay. Another substance or another group of materials is okay, which can be metabolized in the liver is going to be drugs. Okay. So primarily, guys, okay, yes. If you, for instance, okay, take any medication. Now here is okay, it's probably that's okay, 90% of the medication that people will take is in the form of a tablet, syrup, suspension, or whatsoever. But you take it by mouth. After that is being, yes, okay, you can say, okay, that pill or solution or suspension or so on so is broken down in the stomach. It is absorbed from the stomach or it's okay, or your intestines into the bloodstream. But before it's okay, it can go on and start working, it has to go a trip by through the liver. And what the liver is going to do is finally, yes, okay, metabolize it. Did that make sense? So some of the drug that you take actually is going to, yes, okay, be lost in the process of metabolism. Okay. Did that make sense? So all, yes, okay, most drugs, prime, yes, okay, taken by the liver, yes, okay, is going to be, yes, okay, metabolized, oh, sorry, taken, is probably going to be metabolized by the liver. As a matter of fact, we can just, yes, okay, mention it, okay, yes. Drugs or drug metabolism by the liver is actually, yes, okay, what they call the first pass metabolism. So we can say the metabolism of drugs by the liver is what we call the first pass metabolism. And it may be strange as okay, even as okay, another substance that okay as may be metabolized by the liver is alcohol. Yeah. Right. Another substance that we may be as okay metabolized by the liver, but mostly as okay, that's going to be as okay anabolized. Anabolism is going to be protein, no, sorry, not proteins. Plasma proteins. Now, I hope all of you remember, yes, okay, what plasma proteins were. The proteins that we had in the plasma. Clear, okay? But why do I say it's okay anabolism? Because it's okay, what the liver still will be receiving is going to be the nutrients, which we in this case are called amino acids. These amino acids may be derived from, yes, okay, different proteins that we consumed. But be brought together to, yes, okay, make up your plasma proteins, which are going to be the proteins that we have in the plasma. And why do we call them plasma proteins? Prime, yes, okay, they were proteins. Main is okay, just made up of different amino acids, maybe derived from different proteins in the first place, but brought together to form different proteins, which then now yes, okay, end up in the plasma. Did you guys get that? Did that make sense?
Yes.
Okay. So you can say, okay, most of the metabolism, because okay, metabolism was okay, either build-up of new things or breakdown of new things. Happens in the liver. We can also say another function that your liver have is going to be as okay, what we can call gluconeogenesis. Oh, okay, sorry. Glucogenesis. Now if you just say it's okay, gluco, maybe it's okay from glucose. Genesis, production. Now what that means is okay, going to be okay, what that means or mean is okay, that this is going to is okay. Not really produced, but actually it's okay. Maybe we can say it's okay, convert the glucose into a stored form. A form in which it can be stored, which we roughly call, or which we mean it's okay, called glycogen. So glycogen is made as okay, just the stored form of glucose. Yeah, okay. So you might have, let's say, as okay, consumed a lot of glucose or things which were rich in glucose. You might not need to use all of it. What your liver will be able to do is pretty much okay as a form of metabolism, if you want to call it that way. Convert some of that glucose that you didn't use into a form called glycogen, which then is going to be stored in your body. Stored, why would you store it? Mainly because you may need it on a rainy day. When you're running low on glucose, this glycogen is going to be mobilized into or converted into glucose and released into the bloodstream. And yes, you have enough glucose.
So when it's stored, is that the inactive form of it? Is that what you
No,
said?
we won't say inactive form. It's just a stored form.
Okay.
Because that's planks of wood at Home Depot are still planks of wood. But right now they're not in use. They're just waiting there for somebody who wants to build a shed in their backyard or something to come and pick it up. Okay, but this glycogen is when it is it to be used, it becomes glucose. Okay. Another function of your liver is that it's going to detoxify. Or detoxify, we can say detoxification. Okay. Now you look at the word detoxification or detoxify. Here's the word toxi. Made as derived from toxin, which made as just a funny word for as poison. Okay. Now not actually as probably not going to be able to as be dealing as with poison. But made as you can say undo as the toxic effects of certain toxic substances. Okay. If one is exposed to in lower doses. Okay. So it's a lot of certain harmful substances or toxic substances that maybe able to enter the body. What are the main organs, structures, or glands in the body that are going to try to undo the toxic effect of those? Is going to be liver pretty much by detoxification. Now, ladies and the gentlemen, yes, one major function that I will talk about of the liver is going to be hemolysis. Now, I hope all of you remember what the word hemolysis meant. The breakdown of the red blood cells. Did you guys get that?
Yes.
Good. Now, guys, what do we have in the red blood cells?
Hemoglobin.
Hemoglobin, exactly, right? Okay. Hemoglobin. Now, we don't want that hemoglobin to be as released into the plasma. Okay, now why is it that a red blood cell needs to be hemolyzed? Why would a red blood cell need to get hemolyzed?
Is it because it's an old blood cell, red blood cell?
It has lived its time, so right now it's okay. It's not going exactly then. It's very good. Okay. Okay. It has lived its time, so now it's time to say, okay, well, okay, thank you for your service. Let us take you out of circulation. So it's going to be hemolyzed. Now, some of you will say, okay, so what's going to happen to the hemoglobin? That hemoglobin as well is going to get chemically broken down. Or you can say it's okay, metabolized, if you want to put it that way. And actually, it's okay, what we can say is okay. So let's do it this way. If you said red blood cell, hemolyzed, yes, okay, have hemoglobin. This hemoglobin, yes, okay, is going to be metabolized and ultimately, yes, okay, end up as a product that we call bilirubin. Did you guys get that?
Can you please repeat that one more time?
Red blood cell is hemolyzed, right? Clear?
Yes.
Good. What do we, yes, okay, get from that? Well, okay, the cell membrane and all that is okay, destroyed. You have hemoglobin. There's hemoglobin here, so okay, it's going to, yes, okay, in the liver. All this, yes, okay, happens in the liver. That actually is okay, going to be what we can call it as the blood runs, that's okay, and okay, cells are being hemolyzed. Okay, the constants of the red blood cell actually is going to, yes, okay, run through, yes, okay, the liver cells. Okay, and as it does so, yes, okay, that hemoglobin is going to, yes, okay, be broken down into, yes, okay, a substance called bilirubin. Did that make sense?
Yes, thank you.
Okay, now this bilirubin here, we can mainly say, okay, yes, that's going to be, yes, okay, a waste product from derived from hemoglobin. Did that make sense? Now, since we say, yes, okay, waste product, what I mean? Get rid of it, right? We need to get rid of it. But how? Now, normally, guys, what this bilirubin here is okay is going to do is going to become, yes, okay, a vital ingredient of what we call bile. So the hemoglobin that is broken down and okay, as produces what you call bilirubin. Well, we need to get rid of it. But how? That bilirubin, yes, okay, pretty much okay, becomes a vital ingredient of the substance that we call bile. Now, in a little bit, yes, okay, we talk about, yes, okay, what's going to be the function of this bile here. But before we get to that, this bile here. Bile is stored in a little sac-like structure called the gall bladder. Did you guys get that?
Yes.
Clear? Okay. So, ladies and the gentlemen, this here says the liver. Okay. In the liver, is okay, we have hemolysis. Hemolysis is okay, produces bile. That bile is okay, is going to be stored. Please mind the word stored in a structure called the gall bladder. Now, for how long? Because red blood cells are continuously being hemolyzed. There's going to be a continuous production of bilirubin, which will cause that there will be a continuous production of bile that will be stored in the gallbladder. So at some point, yes, okay, this gallbladder is okay, has to empty itself. Did you guys get that? But before we get into this, okay, how and when it's going to empty itself, let's just talk a bit about okay, what is the function of bile. And this pretty much okay is going to play a role in the digestion of fats into what we call fatty acids. Okay. So although it's okay, if you look at it, bile was derived from a waste product of yes, okay, bilirubin, which was produced as okay, as pretty much okay, no good red blood cells being broken down. But you can say it's okay, nothing goes to waste. Even waste is not waste because even waste has a function here. Okay. Now, you guys remember what I said earlier, that okay, yes, from the gallbladder is going to be yes, okay, a duct called the cystic duct. Okay, and that's pretty much going to be as okay via this duct that the bile from the gallbladder will be released into the cystic duct, and okay via the cystic duct, yes, okay, it opens up into the duodenum. And what is it that is going to do in the duodenum? Digestion of the fats into fatty acids. Did you guys get that? Okay. Although we also said that, okay, yes, on its way, yes, okay, this cystic duct here will be joined by a duct that we call the hepatic duct. That as well also has okay with certain, yes, okay, release certain substances But the union of these two, cystic duct and the hepatic duct, became, it's okay, what we call the common bile duct. Or as we say, it's okay, the CBD. Okay. Did you guys get that? But the question still arises, what causes the gallbladder to start secreting, yes, okay, the bile into the bile duct, which will be met by the hepatic duct, become the common bile duct, and okay, as release the secretions into the small intestine. Or in this case, that's okay, the duodenum. Because this bile will only be needed in case that there was some fatty contents in your small intestine. And where are those fatty contents going to come from? You just had the biggest supersize me meal from McDonald's. No, okay. Okay. Whenever you eat a fatty meal, a meal that is going to just, okay, contain fat. Okay. Ultimately, as okay, that fat is going to make it from the stomach to the small intestine. Did that make sense? And that's, no, yes, okay. Our bodies are big chemical factories. At that point, let's put it this way. We say it's okay, we have the duodenum. Let's say it's okay. Fatty contents enter the duodenum. Did that make sense? What these fatty contents in the duodenum is going to do is mainly cause the duodenum to produce a substance which is going to be called cholecystokinin. And what that cholecystokinin is going to be doing is going to be acting upon your gallbladder and pretty much cause the gallbladder here to squeeze. And when it squeezes, it's going to push the bile from the gallbladder into, yes, okay, the cystic duct. From the cystic duct, it will go, the cystic duct will join by the hepatic duct, become the common bile duct, and release into the duodenum, whereas, okay, the bile now is, okay, can act upon this food, as, okay, this fat here, to divert it into fatty acids and make these absorbable by the blood. Did you guys get that? Okay. So what may happen, for instance, okay, if somebody had a, okay, probably not the favorite color. Let's see. A gallstone. Now gallstones can, yes, okay, build up in the bladder. Okay, let's go ahead, that would be gallbladder stones. But it's okay, they can also move from the bladder into the cystic duct. They can go into, yes, okay, the common hepatic duct, or common bile duct, sorry. Okay. Did that make sense? And okay, yes. Well, okay, if they block the ducts, what's going to happen? Well, okay, the bile remains, okay, first accumulate in the bladder, gallbladder, because, okay, it can't get out. Ultimately, it's okay, there's going to be, it's okay, you can say a backflow of bile. Okay. And maybe it's okay, that will block is okay, the flow of bilirubin from, yes, okay, the cells in the liver. And this bilirubin actually is okay, will backflow into the blood. And when we have, okay, a high level of bilirubin in the blood, that's what's called jaundice. Have anybody ever heard of jaundice?
Yeah.
Good. So that's pretty much, okay, what happens. Clear? Okay. Okay. So the reason that, okay, yes, the skin primarily is, okay, the sclera of the eye appears yellow is mainly because of the accumulation of bile in those areas. Okay. How did it accumulate there? Mainly as, okay, because it was high in the blood, and it means, okay, it went from the blood into the other tissues. Did you guys get that? Okay. Now in newborns, it's normal to develop jaundice. Okay, not something that you want to happen, but it's okay if it occurs. Well, okay. They just want to make sure, okay, it doesn't go out of control. Okay. Now, when you talk about grown or elderly or also older people, well, okay. Two reasons: either too much hemolysis can be a reason that you end up as, okay, producing too much bilirubin for your body to be able to just, okay, get rid of. Second, if there's a blockage in, yes, okay, your outflow of bile. Okay. Common bile stones. Okay. There's even, yes, okay, a kind of tumor of the bile ducts that they call it, which is going to be as, okay, cholangiocarcinoma, or cholangiocarcinoma, sorry. Chole from gall, angie, yes, okay, for the duct, and carcinoma, cancer. So cholangiocarcinoma. Okay. Cancer of the bile ducts. And again, not a friendly fellow to be dealing with. Did you guys get that? Okay. And please, 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 please remember this fellow here is, okay. Cholecystokinin. Chole is for gall, cyst, bladder, kine, yes, okay. Main, yes, okay, comes from, yes, okay, the word kinetics, which means motion or movement. So pretty much, okay, the substance which is going to cause the movement of gall or sorry, bile from the gallbladder. Okay, or where was it produced? In the duodenum. What was going to be the mechanism that triggers the production of cholecystokinin was fatty contents entering the gut, or duodenum in this case here. Did you guys get that? Now, guys, let's just okay. Let's just look at this fellow here. Okay, so you guys can see the picture of the liver?
Yes.
Good. Okay. Okay. So liver is okay, the largest gland of the body. Everybody got that one right? Okay. Clear? Okay. So this is the anterior surface of your liver. Okay. Now, just to talk about this fellow here. Now, this is what we call the ligament falciform. It should be mentioned somewhere. Okay. No. Okay. Falciform. Okay. Now, what's going to make that? Okay. Now, this is pretty much okay, yes, on the anterior abdominal wall. What we have is on the right side comes peritoneum on the inside or lining on the inside of the anterior abdominal wall. And so do it come from the left side. Okay. And they pretty much okay, yes. So it's okay. It is for the inside of the anterior abdominal wall. Peritoneum comes like this, meets here, and again, 2 layers of peritoneum, one from the right side, one from the left side, meets and made us okay run between anterior abdominal wall onto the anterior surface of the liver. But made us okay forms a ligament-like structure called the ligament falciform. Okay, now when it goes onto the liver, what came from the right side of the anterior abdominal wall is going to just okay merge onto the right side of the liver. What came from the left side of the anterior abdominal wall is going to merge onto the left side. Did you guys get that? Okay. Okay. So what is this? We can mean this as okay, ligament falciform, but what do we have? We can say it's okay. There's going to be the parietal peritoneum, coming from right side, coming from left side. And what's going to be deeper to that? Visceral peritoneum and visceral peritoneum, coming from right side and left side. Okay, but this all together here is going to be as okay what we call the ligament falciform or falciform ligament, whichever. Okay, which means okay runs between the anterior abdominal wall and the liver. Did you guys get that? Now, guys, if we look at the liver, yes, okay, now since this is an anterior view, this means, yes, okay, it's going to be the right side, and this is going to be, yes, okay, your left side. Okay, so your liver pretty much, okay, now your liver has a total of 4 lobes. Okay, but 2 of those 4 lobes are mainly, okay, easily visible from, that's okay, when you look at the liver from the anterior side. Because the biggest lobe is going to be this fellow here, which is going to be the right lobe. Clear? The second biggest lobe is going to be this one here, which is your left lobe. Yeah, okay. And what pretty much, okay, marks the separation between these two is going to be as, okay, your falciform ligament. Did you guys get that? Any questions about that? Nope. No questions?
No.
Good. So what did we say? Whoopsie, whoopsie. That's not the color for our liver. It says, okay, this was the liver. And this is an anterior view. Okay. So here we can say, okay, we had the right lobe. We can say, okay, we have the left lobe. Okay. And on the surface, the structure, I mean, is okay, I was going to mark what is your right lobe and what is your left lobe. Was this ligament that we call the ligament falciform. What is this ligament falciform made up of? Peritoneum coming from the anterior or inside of the anterior abdominal wall on the right, and peritoneum coming from the left side of the inner surface of the anterior abdominal wall. Meets together on the falciform ligament, goes onto the liver, splits at the liver. What came from the right side goes up against the right lobe, what went on the left, came from the left side, goes up against the left lobe. And maybe that's okay, is going to turn around the liver, meet at the back, and okay, yes, from there, yes, okay, go to the stomach, forming the lesser omentum. Now, guys, if we just, okay, so we said we had the right lobe, we had the left lobe. Now, if we just look at the back side of the liver, so now this is going to be, okay, the right side of the liver, this is going to be the left side of the liver. Okay, or we can say, okay, this here is, okay, was your left lobe. And we can say, it's okay. Let's just, okay. This is your left lobe on the back side now, okay? We're looking at the back side of the left lobe, and we're looking at the back side of your right lobe. Okay. This is actually going to be as okay where we have the 2 other lobes. Okay. And one of the lobe is going to be called the quadrant lobe. And it's going to be here. Other lobe is going to be, it's okay, what they call the caudate lobe. That's it.
This is on the back side of the liver, these
Yeah.
ones?
That's my dear. Okay. So what were the 4 lobes of your liver? The right lobe, the left lobe, the quadrant lobe, and the caudate lobe. Did you guys get that? Yes.
Yes.
And with that said, that was all that I could offer for the digestive system. Now that is a bit of a cookie to chew on. Right? But at the end of the day, my thing is make sure that you masticate before you deglutate. And if you fear that you're going to get choked on it, because even though it's okay, you masticate it extensively, and you still can't swallow it, then it's okay, you can always, it's okay, gag in the form of a question.
Quick question before you leave. The quadrate is on the left side or the right side in the back of the liver?
Well, right or left,
It doesn't matter, like it's just in the back?
it's going to be, it's okay. Okay, so that should be upper, and okay, so
Oh, it's gonna be like in the quadrate is gonna be like in the bottom. No, quadrate.
yeah, caudate is going to be, it's okay here, down.
Right, so the quadrate should be in the bottom, the quadrate should be up a little bit up, no?
Mhm. Yeah.
Okay.
Yeah.
Thank you.
No problem.
All right.
No problem. Okay, guys. Then I see you guys tomorrow. Let me just make sure that I make our links, Zoom invites. So that's okay with a new chapter, a new system called the urinary system.
I had a quick question just to clarify.
Sure. Yeah.
I know I asked you before about the final, and the date that was on the syllabus was the 17th.
No,
But
it's not the 17th, my dear.
it's the 20th now on the syllabus.
Yeah, it's the 20th. I had to correct that one.
Okay, so
We push it one day because of what you call it, Good Friday or whatever.
okay, so the final's on the 20th now.
Yes, my dear.
Okay, thank you.
No problem. Anything else?
Yeah.
Okay, guys, then I guess I see you guys tomorrow. Same place, same time.
Sounds
See you
good.
tomorrow.
Okay, have
Thank
fun. Deb.
you.
Okay,
Thank you.
bye, Deb.
Bye. Thank you.
Bye, Deb.